Now let's continue lecture 4 part 2. So we are here. So we finished this part, capacitor input filter as an filter, and we know what is the filter. Then we will compare the filter as a full half-wave rectifier, as we say, charge and discharge for the capacitor, and this is for full half-wave rectifier. If we apply a full wave rectifier, as we know, all of part is a positive, so the negative, it will be up. It depends on the polarity that we take it from bridge. And we have this area as a positive, so the ripple here, it will be minimum than the half wave. So this is the advantage for full wave. Now if we take it just this one and this one, and we take it like this one, we call this part from here to here is a ripple, the name. So the ripple is R V ripple peak to peak, peak to peak, and over VDC. So this one is the VDC in the middle from here to here, and for this one is a peak, as you can see, V rectifier peak for up and down. So this one is a DC in the middle, and we have ripple peak to peak. This one is a peak to peak, and this one is just one peak, and the ripple is V ripple from here to here. So this one is a ripple, V ripple, voltage for ripple. Now, so this is a comparing between two of them. V ripple for peak to peak, 1 over frequency RC, as we say, it's depend on the resistance and capacitor, and the other one is a VDC, it's nearly equal. So this one is a nearly equal, 1 over, so this one is a the same, this one, this one is a volt DC and ripple peak to peak, DC for DC. Multiply, here's a multiply by V ripple from V ripple, 1 peak. Okay, so we finished from full wave and half wave rectifier and comparing by a ripple that they have it. Now we have another applications is a Zener diode. Zener diode, this is the configuration for the Zener diode. Zener diode also, it is a diode contains from semiconductor material, and it is also from germanium, silicon, same thing, but the difference between them that when we have the characteristics between V and I, we have here, this one is the same, the normal diode, but the other in the reverse, it will not cutting that they get off voltage, but we have small current and small voltage. Not the small, it depends on what we have in a source. We can see later. So here we have a voltage. So there is nothing means cut or off. It will be off in conditions we can see, but normally we can specify or we can manage to get the voltage here. Okay, so one of the applications for Zener diode, it is very important and useful in the electrical devices. Its name regular voltage or regular divisor, regulator. Sorry, the regulator voltage. Now let's see the defines the analysis of network employing Zener diode is quite similar to that we applied in analyzing semiconductor. Okay, Zener model, it's employed as on state will be shown in this figure, defined by voltage less than V Zener but greater than, so V Zener but greater than 0 volt, with the polarity indicated in this figure. Let's see, if we have on, it will be V Zener, batteries, like a batteries, and we have the voltage that we have, that we will apply, like 0.7 volt if it is germanium, and 0.3, so there is a DC voltage. Now if it is V Zener, if this one greater than the voltage that supplied and greater than 0, this diode, it will work as off diode. But for now we will take this example. Let's see, an example, it will be obviously shown the different at what we want to say. Now we have V in 16th volt. Okay, this one 16th, V Zener is 10, so 10, it's less than V diode. Let's see, so it will working as a normal diode. As you can see here, it will be threshold and it will be here. So the diode, when we get V load and we have V, so you can see V, and it will be 0.83 for V load, so it will working as off diode, off circuit. Then if we apply the voltage here, since it's very important here, since V 8.7 is less than V Zener, the diode is off state. Okay, if we have this one and you apply it, okay, since here if we have 0.8 and 0, and for point P we change it here for A, determined, and we got this one for point B, if we have R load here applying, and we get from R load to apply this equations, we get V 12. So since V is a 12 is greater than V Zener, then the diode will be on. Now we can controlling the circuit depend on how much we have in our load. So if we change it, so we can change the load. If it is up, the voltage up here, okay, and we can get the circuit as an on state always, okay, and we can get the off state. So this is the difference between the normal diode and the Zener diode. We have this characteristics. Now we change, okay, the other things, and we have here fixed VI, variable RL. Now we can, if we want to change it to another we can say device or another practical applications, due to the offset voltage for Zener, specific range of resistors value. So now we can say it will doing as a regular changing for R load. You know, in the experiment lab we do like that. It is changing variable R, So the R always changing. We can switch it, like switch point, like a switch, and there is another here like that. Here you do it in for the first lecture, for the first lab, for say 1 kilo ohm here, and here's the 0.2 kilo ohm, and then you have in your board 10 kilo ohm. Okay, so this is the regular resistor. Now variable resistor. Now fixed the voltage, varying the R. You have this one, it will be like that, be Zener, it will be, because it will be fixed here. So this is the equations, I want you to know it. Then V load, the same thing, it will be solving from this one if we're changing R here. Okay, and you need this one to use it. Similar that we explain it. This is so easy. Now example, this one, we can solve this example. Okay, let's see, changing the variable, and you will apply all the other equations up. Okay, and if you have any question, I will help you to answer it. The other thing is fixed R, variable VI. So two point, it's very important to apply the Zener diode. First of one, if you change VR, fixed, if you change Vn, so now here's the Vn changing, like switch, variable switch here. Okay, variable supply. You will fix VR or the load, and the first one is variable R fixed in. This is what we mean regulator. You have this example to solve it, the same equation that we use it, the first one, this one, and this one. The plotting be like that. Now, if we put two diode, Zener diode, now we have 5 and 5, it will be 10 Zeners, okay? Zener diode, Zeners, and you get 10 by 10 up and down, okay, for the signal here. Now, the last one, voltage multiplier circuit. Voltage multiplier circuit, you have the last, not the last one, the we have this one and this one, light emitting. Voltage multiplier circuit is the circuit voltage multiplier employ to maintain like state relatively low transformer peak voltage while stepping up the peak output voltage to 2, 3, 4 or more than times the peak rectified voltage. So that means if you up the voltage, you will get twice or triple. So this one, it will give you triple, as you can see, triple voltage, twice, double, triple, and this circuit is regulator 4-4. So while you have more than voltage, more than capacitor and diode, while you have multiplying voltage for the output. So if I put voltmeter here, I will get for example 20 volt, okay, and here is 10 volt, okay. if I get here, it's triple, that means 330. If I get here output from here to here, I will get 20 volt, and from here also 40. Okay, so this is the application, one of the application to using ideal normal diode, not Zener. Okay, capacitor, diode, and transformer. The last one is light emitting diode, one of the applications that we use it. The main of impulses, the light emitting diode, it's called light emitting diode, that means there is a light, so the electrons it's emitting, so there is a light, it will be here when we connect it as output from here to here, as you can see. So this the diode, it will be emitting if I got voltage here. Okay, it will be give off visible light when it is energized in any forward bias PN junction and within a structure and primarily closed to the junction. Recombination of holes and electrons. So okay, this recombination requires that the energy possessed by the unbounded free electrons, so there is a free electrons, by transferred to another state. In some materials such as germanium, resined, and it is will be a resined phosphide. So this is the name of material, or flix GASAS and B, and not germanium, sorry, gallium, or we can name it as gallium phosphide, the name this one instead of this one. The number of photons of light energy, so there is an energy emitted is sufficient to create a very visible light source. So if this material we apply it as a diode PN junction, okay, Phase or PN junction here, it will give us a light, so we use it like this one as application. You can see. Okay, so for this is for the last things we have it on lecture 4, and I want you to do as a homework drawing 2 of applications that we learn into this lecture 4. You have, for example, we have this light emitting, and we have this application. Also we have other applications, and you have here, so all the applications you have it, or you can do you get from the internet one of our circuit that we see in, for example, this one. This one of the applications that we got in using transformer, bridge rectifier, any applications you want to do it, just 2 of the that the material or the devices that we're using today, you can give me as a homework 2 of them. Thank you to listening. See you later.